Hi students, welcome to today's class. Today I am going to explain in the chapter linear differential equations. I am going to explain what is a linear differential equation. So we have seen already what is homogeneous type of differential equations. Now we are going to see the linear differential equations. So linear differential equations are of basically two types. So these are our two types. The first one is linear differential equation in y. Second one is linear differential equation in x. Okay, na? In y and in x. What is the form of the linear differential equation in y? So this is of the form dy by dx plus p of x into y is equal to q of x. So you have already wrote p of x and q of x means they are the functions of x alone. That means I will give one example. So dy by dx plus x square into y is equal to some sin x. So here p of x is x square, x alone. Q of x is sin x, a function of x alone. This is called linear differential equation in the variable y. Okay, now coming to linear differential equation in x. So this is of the form dx by dy plus p of y into x is equal to q of y. Q of y. Here p of y and q of y are two functions of y alone. For example, so dx by dy plus cos y into x is equal to some y square plus 5. So that is called linear differential equation in x. How to remember, sir? So if it is a top y is there, therefore it is a y, 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 y. Therefore linear differential equation in y. Here x, x, top. What is the top? X in the numerator, x. Here also x. That's why x should be there. Therefore it is a linear differential equation in x. To solve this problem, to solve this type of linear differential equations, first thing what you have to find out is integrating factor. Understand this? Integrating factor you have to find out. What is that integrating factor? Is e to the power of integral of whatever is here, p of x into dx. Whatever may be the y coefficient function. Y coefficient, what is that? P of x into dx. Okay. Then you will get the general solution. What is the general solution is y into integral factor is equal to what are the remaining function? Q of x into integral factor dx plus c. Understand this? So first function f of x, whatever may be that here f of x, we will make use of that function p of x for finding integrating factor. The second function, that is q of x, we will make use of here, q of x into integrating factor d of x plus c, that is y into. If it is a linear differential function, it is y into. Same likewise we will apply there. Just interchange the roles of x and y, that's all. Here the integrating factor is, if is equal to e to the power of integral of p of y dy. E to the power of integral of p of y dy. Here p of x is there, there p of y is there. Here with respect to dx, there with respect to dy. Okay, now. Then what is the general solution? General solution is equal to here y into there x into. So x into integral factor is equal to integral of, this is q of y into integral factor dy plus c. So while studying these two type of linear differential equations in y and linear differential equation in x, comparatively you study. So first this is a linear differential equation in y, p of x, q of x. Integrating factor. First we will make use of this function p of x, that is e to the power of integral of p of x dx. Okay, now So, what is general solution? Y into integral factor, integrating factor is equal to integral of q of x into integrating factor d of x plus c. Okay. So, if you remember this, everything is here will be just interchange the roles of x and y. Well, in place of x, y will come, in place of y, x will come, that is all. So make use of this. First of all, you concentrate on this linear differential equation y. Now, I am going to show you then what is the proof for this. So, what is the proof for this? So, I am going to teach you the proof. You may ask this, sir, what is the necessity of learning the proofs or yes. So, those who are merit students, those who are seriously preparing for JEE mains examination, you learn the result, the proofs are also you learn, so that it will be remembered forever. If you simply by heart the results, simply by heart the results, there is a chance of getting confusion. Okay. So, let us see the proof of this. What if it is a given linear differential equation, how we will get this general solution. Okay, na? So, let us see the proof. Welcome back. So, let us take the linear differential equation. So, the linear differential equation is, so dy by dx plus p into y is equal to q. So, here I am not writing p of x and q of x. So, you can understand that those are p and q are the functions of x alone. Okay, now, then how to find out the general solution of this linear differential equation in y. So, for that, multiplying with integral e power p dx on both sides, integral e to the power of p dx. You may ask one doubt, sir, integral of p dx if you multiply with on both sides, then how can we say that plus c should be their constant of integration. But the thing is, we are simply multiplying this with to make you into getting perfect differential coefficients. Okay, na? So, there is no chance of plus c will be here. Generally, if it is integral of p of d of x there, so there should be some plus c will be there. So, no need to writing plus c. Okay. So, just you multiply this. So, this is equal to dy by dx into e to the power of p dx plus p, we can write down y into p into integral of, sorry, e to the power of integral of p dx is equal to q into integral of p dx. Okay. So, e to the power of integral of p dx, e to the power of integral of p dx, e to the power of integral of p dx. Okay. So, now you put it like this. So, dy by dx into e to the power of p dx plus, this is, can you write down derivative of so sorry. So, this you put y like this. This is a d by dx of integral of e power integral of p dx. Can we write it as q into e to the power of p dx? Okay, now, sir, how can you write it, sir? Yes, I will show you. Tell me how to write. First of all, here what is there? E power x. What is the derivative of e power x? E power x, e power integral of p dx. Again, what is the derivative of integral of p dx? Here integral and differentiation both will get cancelled, you will get p only. Understand this? Very nice. So, if you observe, this is just like a by parts formula. Up to here, there is a by parts formula is there. So, this is a derivative of y into e to the power of integral p dx is equal to q into, this is a, that is a d by dx of q into e to the power of p dx. See here, is it not that form? As a grouping the terms, that is if you take that y into the derivative of this plus e to the power of p dx into derivative of y, dy by dx, grouping the terms. Next, what we will do? So, next we will do integrating on both sides. So, if you integrate on both sides, so you will get here y into e to the power of p dx is equal to integral of q into e to the power of p dx into dx. Okay, now, so just now that's y into, this is called integrating factor, q into integrating factor into dx. So, this is your proof of solving linear differential equation in the variable y. So, y into integrating factor is equal to q into integral of q into integrating factor into dx. Okay, na? Right. I hope that you understand this proof. Similarly for dx by dy plus p of x is equal to q. So, linear differential equation in terms of x also you can find out. Okay. So, same proof also you can. So, if you learn the proofs are also, those formulas will be remembered forever. Okay, na? I hope that you understand this concept. Let us see some problems based on this linear differential equation in both x and y. Okay, right. Welcome to this problem. So, I have taken a very small problem to make you understand how to solve this is a how to solve the linear differential equation. So, in examinations they will give just solve one differential equation. So, you have to understand this, they do not mention that, so this is a homogeneous type and this is a linear differential equation in y, or this is a linear differential equation in x, otherwise it is a non-homogeneous differential equation, otherwise you can solve this problem using grouping. Nothing will be mentioned. The only thing what they will give is simply they will say solve and there will be a differential equation. Okay, very important for JEE mains examination this is. Okay, na? Right. Then how to solve this? By seeing this, you can write it in the linear differential equation form. Then how to write it? So, dividing with x square on both sides, that is a dy by dx plus 1 by x square into y, that is equal to 1 by x square. So, this is a linear differential equation of in the y, and it is a p and it is q. So, to solve this, first what have to find out? We have to find out the integrating factor. What is integrating factor? E power p dx. That is integral of what is p here? P is 1 by x square dx. So, this is e power minus 1 by x. So, integral of 1 by x square is equal to how much? Minus 1 by x. Okay, now. So, we got the integrating factor. So, let us see the general solution. What is general solution? Y into integrating factor is equal to integral of q into integrating factor dx plus c. So, what is your y? Y only. So, what is your integrating factor? E power minus 1 by x integral of what is your q? Q is 1 by x square into e power minus 1 by x dx plus c. Then, so what will be your answer? So, this is equal to y into e power minus 1 by x. So, here how to solve this problem? Okay, very nice, don't be panic about this. So, if you put this is equal to t, minus 1 by x is equal to t. So, what is the derivative of minus 1 by x? This is actual 1 by x derivative is minus 1 by x square, already minus is there plus x square, that is 1 by x square dx you will get. Then what is the derivative integral of e power t? E power integral is e power t only, that means e power minus x means e power minus 1 by x plus c. C is the constant of integration. Either you can put it like that, otherwise you can multiply with e power 1 by x on both sides. So, this is y into e plus c into e power 1 by x. This will be your final answer. Okay. So, this is the equation of the family of curves whose solution is this, that is whose solution is x square into dy by dx plus y is equal to 1. Okay, now. So, this is a very small problem. The first thing is whatever may be the linear differential equation is given. So, you have to write it in this form. First, to identify the p function and the q function. So, p function, q function both should be in a single variable. It should be there x, otherwise y. Okay, now if it is a x, then it is a linear differential equation in y. First find out integrating factor. After finding integrating factor, multiply the integrating factor on both sides, that is a general solution. So, here p of x is useful to find the integrating factor, and here q of x is useful for finding the general solution. Okay, na? Right. I hope that you understand this solution. Let us go for one more problem. Dear students, welcome to this second problem. So, solve x plus 2y cube into dy by dx is equal to y. Then what we will do this? So, first of all we have to identify this, either it is a linear differential equation in y or x. Okay. So, first generally whatever may be the general students, what they will do, dy by dx is equal to y upon x plus 2y cube. Okay. Just I have taken to that side. Observe the right hand side part. Can we split into two terms? Can we split into two terms? We cannot split. Why? Because here denominator x plus 2y cube is there. So, if you make into reciprocal, if you take into reciprocal, then we can split into two terms. So, let us take the reciprocals. That is equal to dx by dy is equal to x plus 2y cube by y. Okay, now you just separate this. So, this is a dx by dy is equal to x by y plus 2y square. Okay, right. So, take the second term to right hand side to make the form, general form. So, what is the general form? So, this is a dx by dy plus minus of 1 by y into x is equal to 2y square. Okay, so, this is a linear differential equation. This is a dx by dy plus px is equal to qy. So, here p and q are functions of y alone, functions of y alone. Okay, now this is a linear differential equation in the variable x. Now, let us find out the integrating factor. So, what is the integrating factor? E power integral of p dy. So, you can easily identify. Why? Because these are y, no, their y only you have to get. So, this is equal to integral of p. P means how much? Minus 1 upon y dy. So, this is equal to e power minus log y. So, this is e power log of y power minus 1. This is y power minus 1. This is 1 by y. Okay, so this is equal to 1 by y will be your final answer. Right. Now, coming to general solution. What is a general solution? General solution x into, there y into, here x into integrating factor, that is equal to into. So, we will make use of this term now, general solution, that is equal to q into integrating factor dy plus c. So, this is a x into integrating factor is 1 by y integral of, what is your q? That is a 2y square into integrating factor 1 by y dy plus c. So, this is x by y. So, 1 y will be cancelled, 2 into here y will be there. What is the integral of y? So, this is a y square by 2 plus c. Okay, so this is a x by y is equal to y square plus c. This will be your final answer. I hope that you understand this solution. Let us go for some more problems. Dear students, welcome to this problem. So, the problem is solve 1 plus y square is plus x minus e to the power of tan inverse of y into dy by dx is equal to 0. Then how to do this type of problems? Okay. So, now what I will do now, so I multiply with here dy by dx is there, no, you multiply with dx by dy. Immediately you can ask questions, sir, how we get that idea, sir, here dy by dx is there, how to multiply with dx by dy. So, if you multiply with dx by dy, the problem will be very, very easy. Okay. So, let us see that. So, this is equal to 1 plus y square into dx by dy plus x minus e power tan inverse of y is equal to 0. Okay, let us take minus e power tan inverse of y to right hand side. So, that is 1 plus y square into dx by dy plus x is equal to e to the power of tan inverse of y. Okay, right. Yes, again, so here dx by dy only should be there. There won't be any coefficient other than 1. That's why multiply both sides with 1 plus y square. So, this is equal to dx by dy is equal to, this is 1 by 1 plus y square into. So, here, so this is I have divided with 1 plus y square on both sides. Now, clearly this is a linear differential equation in the variable x. So, here So what is your integrating factor? This is e power integral of 1 by 1 plus y square dy. That is tan inverse of y. Okay, that is your integrating factor. Then what is our general solution? General solution, remember that if it is a x, you start with the x. X into integrating factor integral of, this is a q, this is p and q, this value is q. This is a e power tan inverse of y by 1 plus y square into integrating factor e power tan inverse of y dy. Now here let us see that. So if you think in a logical way, if you put e to the power of tan inverse of y as t, e to the power of tan inverse of y is equal to t. So if you differentiate with respect to y on both sides, what you will get? E power tan inverse of y derivative is e power tan inverse of y. Again tan inverse of y derivative is 1 by 1 plus y square. That means, so you are doing integral of t dt. What is the integral of t dt? T square by 2. So that is equal to, see here, so your answer is x into, what is the integrating factor? E to the power of tan inverse of y is equal to t square by 2. That means e to the power of tan inverse of y whole square by 2 plus c. That is equal to x into e power tan inverse of y by e to the power of 2 times tan inverse of y by 2 plus c. This will be your final answer. Understand? So very nice problem this is. The only thing, idea, technique that what you have to get is, here dy by dx is there, no? Here you have to write down dx by dy, multiply. Otherwise, how we will get this idea? The thing is, general students what they will do? They will start dy by dx, take that side, okay, minus 1 plus y square by, divided by, so x minus e tan inverse of y. Just make it upside down, take the reciprocal, then you will get the answer. Okay, now, so putting like that you can't do anything. So if you take it into reciprocal, the problem will be solved. Okay, right. I hope that you understand this solution. So let us go for next problem. Dear students, let us learn what is Bernoulli's equations. Okay, so there are certain equations are there. They are of the form dy by dx plus p of y is equal to q of q. So if it is in this form, we call it as a linear differential equation in y. We know the procedure to solve. But there are certain equations are there you will get here y to the power of n. Here y to the power of n. So here y power n will be there. There is a function y to the power of y square, y cube, y to the power of 5, like that will be there. This type of equation is called Bernoulli's equation. Okay, Bernoulli's equation. Then how to solve such a type of Bernoulli's equation is, the first thing what you have to do is, whatever may be the quantity here, q into, so here p and q are functions of x alone, you know that. Whatever may be the quantity here, y power n, you divide y power n on both sides. So this is equal to 1 by y power n dy by dx plus this is y by y power n p is equal to q. Understand this? So this will be 1 by y power n dy by dx. This is equal to 1 by y to the power of n minus 1 p of x is equal to q of x. So this is a one type of equation. Then how to do this problem is, the first thing what I told you, this first step is dividing with y power n. Whatever may be that you divide with that term. The second term what you have to remember is, here definitely something number what you will get here, whatever may be that. So p of x coefficient, that is y by y power n minus 1. You call it as some v or u or anything. Then what you will get, so if you differentiate, this is equal to y to the power of this is 1 minus n is equal to dy. So, if you differentiate this, automatically you will get a linear differential equation form, then you can get, you can easily solve it. Okay. I will explain this concept using a small problem so that you can understand easily. Okay. This is a linear, Bernoulli's equation. Then first step what you have to do is you divide with y cube on both sides, whatever may be here, So, here one thing is here, no, whatever may be that you divide with on both sides. So, this is equal to 1 by y cube dy by dx plus, if you divide with by y cube, so already this is a 1 by y square, this is 1 by x is equal to 1. Okay. The next step is whatever may be here, that is, so this is equal to some p and the term is q, whatever may be that 1 by y square is there, you call it as some v. Put 1 by y square is equal to v. Now, differentiating with respect to x on both sides, y on both sides. So, you will this is equal to how much? This is equal to minus 2 by y cube dy is equal to dv. So, dy by dx, otherwise dy by dx is equal to dv by dx. So, y power minus 2, that is minus 2 into y power minus 3, that is y cube. So, take minus 2 to that side also, this is 1 by y cube dy by dx is equal to minus 1 by 2 dv by dx. Okay. So, this is 1 by y cube dy by dx. I will write down minus 1 by 2 dv by dx. Now, resubstitute here, minus 1 by 2 dv by dx plus 1 by y square. I will write it as a v into 1 by x is equal to 1. Okay. Now, you multiply with minus 2 on both sides. If you multiply with minus on, so this is a dv by dx. So, this is equal to minus 2v. Otherwise, you can write down this as a minus 2 by x into dv is equal to minus 2. Okay, now, so this is equal to, I am multiplying with minus 2 on both sides, dv by dx minus 2 by x into v only, here not dv, simply v, see, is equal to minus 2. So, this is a linear differential equation in y and x. So, then what is the integrating factor? So, integrating factor, so in place of v, in place of y, v is there. Okay, na? So, same procedure. What is the integrating factor? Is equal to e power minus 2 by x dx e power minus 2 by x dx. That is e power minus 2 into log x, e power log x power minus 2, that is 1 by x square. Understand? So, 1 by x square will be your integrating factor. What is the general solution? There we write out no, y into no, here v into. So, v into 1 by x square integral of 1 by x square into whatever may be the term here, minus 2, that you have to write down, minus 2 dx plus c. So, this is v by x square is equal to, take minus 2 common outside. So, what is the integral of 1 by x square? 1 by x square means x power minus 2, that is equal to minus 1 by x. So, x power minus 2 plus 1 by minus 2 plus 1, x power minus 1 by minus 1, minus 1 by x plus c. Minus minus will get cancelled. In place of v, substitute 1 by y square. So, this is equal to 1 by x square, y square is equal to 2 by x plus c. This will be your final answer. So, very nice problem. This is the first thing is identifying this as a Bernoulli's equation. Whatever may be here y cube, you divide with the term. Whatever may be comes here, that means x function will be there now before that coefficient 1 by y square. Put it as a y, then you proceed, automatically you will get a linear differential equation in y. Then general procedure you have to solve it. Okay, now I hope that this another type is also there. Something, for example, if here dx by dy is there, here y function it is there, some x will come. Here if it is x cube is there, dividing with x cube on both sides. You will get the solution. Okay, now. So, I hope that you enjoyed today's class with some more topics and some more problems from this Bernoulli's equation, linear differential equation and previous JEE mains examination. I will teach you tomorrow's class. Until then, all the best.